Well, hello and welcome back to Adrian's Digital Basement. On the bench here, you see the Samsung S5200 laptop with a plasma screen that I've recently worked on. To summarize, if you haven't seen those videos yet, this machine is a 286 with a gas plasma screen that needed some repairs. I got it working, but unfortunately, the plasma screen in this thing has a bond failure that's causing all sorts of display issues, and it's not fixable, not without swapping out the entire panel. And these panels are very expensive. So on today's video, we're going to be taking a look at another laptop from the late 80s that also has a gas plasma screen. And maybe it works a little bit better than the one on this machine does. So without further ado, let's get right to it. This comes from, well, I'm actually not totally sure who it comes from, but I'm sure we'll find out with a letter inside, but it comes from Frankfurt, Germany. So hi to all my German viewers. Let me cut into this and see what's in this rather large box. It does say on the top, open here, find note on this side. So yeah, unlike the last mail call episode where I misplaced the notes because it was in the box somewhere and it came out with all the packing material. This time I know there's a note, so I'm gonna look for it. And yes, there it is. We got the note. Let's take a look at it. All right, so this package comes from Peter, and as it says here, as discussed, I'm sending you the Schneider PC 7640 quote laptop. After watching a video on the Samsung S5200 with a gas plasma display, which unfortunately was impossible to fix, I saw a listing for the Schneider machine on a local trading site. It's called Marketplaats. Your Dutch viewers will know it. It's similar to Craigslist, I believe, and had a working glass plasma screen. I reached out to the seller and I told Bernard I was planning to donate the machine to your channel, and he kindly offered to give the machine to me so I could ship it to you. Kudos to Bernard. The machine does have some other issues. The hard drive does not spin up. It's a 3.5-inch MFM hard drive, which I don't think is very common, but with some help, the spindle motor does start. It may need some of your bearing oil. I tried booting from the floppy disk after cleaning the heads, but that also did not work, although Bernard did have some success in that matter. Bernard also sent me a zip file containing the software and service manual that came with the machine. The service manual was already available on archive.org, and I've uploaded the software sets. So I've added a QR code at the bottom so you can find these easily. And let's flip this over. And there it is. I wanted to include some candy, but they made the package go over 10 kilograms and it would double the shipping cost. Wow. I hope you don't mind that too much. Of course not. And yeah, I'm glad that you were able to save a little bit on the shipping cost, because I can only imagine how expensive it probably was as it is. Anyway, looking forward to seeing a video or two on this machine. Cheers, Peter. There's the service manual QR code and the software QR code. So pause your screen, take a picture of those if you want to look those up. Thank you, Peter, for that nice note. Let's dig into this box here. It's packed with that foam that can actually like form fit around things. So that's pretty cool. Here is the computer. It was very, very nicely packed. So without a doubt, 100%, this thing survived shipping. Take a look at that. That's that foam I was talking about. Not sure if this foam was originally for this computer or not, but either way, it was very tightly cocooned in there. So yeah, this thing absolutely survived. Looks like we have a plug here that is a European style 240 volt plug. Hopefully this computer here actually supports 120 volts. It may not, but that's okay actually, because I do have a step up transformer if that is necessary. All right, and when Peter said laptop in quotes, that was because this thing, much like that Samsung computer, is an absolute beast. It is incredibly heavy. Looking around this machine, here we have a floppy drive on that side. The front, oh, it's heavy. It's really heavy. It doesn't really have much here. These are probably release the screen. Yep, it does, and that's not broken, unlike on the Samsung. Whoa, this thing. It's not as big as the Samsung. It seems like it's easily as heavy as that machine. Serial monitor, so it's digital output, so 9-pin, so CGA or EGA. We have, looks like FDD floppy drive here, and then the port closer to the left side, closer to me, is obviously the parallel port. This is hurting my arms to hold this up. And over here it says EXP, so maybe there's like an ISA bus slot in there. And then we have a power connector. flipping the computer over, I do notice here that we have a handle. That's something the Samsung didn't have. It seems stuck. There we go. Yep. Okay. So we have a carry handle with metal sides. And on the sticker on the bottom here, PC 7640 and 220 volts, 50 hertz, 125 watts. And what is this, an identification number here? Is this a version that is from the Netherlands? That might well be the case, right? So someone else will probably be able to decode this a little bit better than me, but it is interesting that it's only 220 volts. That's not the end of the world though, because 220 volt power supplies can often be converted to 120 volt operation. I've done it before. So probably the first thing to do here is I do want to power this thing up since it's already been powered up. There's no reason to, well, wait on that, but I'm going to use a step up transformer, obviously. And that way we don't possibly damage the power supply. You know, I've heard it's possible that a switch mode power supply, if you give it too low of a voltage, can be damaged. Obviously, if it's designed for 120 volts and you give it 240, well, that's bad as well. But if it's designed, well, it's designed to operate on 220, you only give it 120, you're giving it half of its voltage. I'm not sure that that's gonna damage it, but maybe because it's gonna try to compensate for that low voltage, the DC part of it that's coming into the power supply and cause some kind of damage. If you are like a power supply engineer and you happen to know if damage can occur from that, then yeah, I'd love to hear about that. What we're going to be using here is my 240 volt step up transformer. And the funny thing about this thing is it used to be a step down transformer. So it was, I think, for use in Europe, and it had an original, I think, UK plug on here. And then the output was 120 volts. Well, I took this thing apart and then I reversed all the components inside. So I just swapped the way the transformer is wired up. And now this thing does, well, exactly what it does. It's a step up transformer. So yeah, it takes 120 volts. So I put a new power cord on here and then it outputs 240 and it's still using a US plug. That means I can just use any old IEC mains thing. Or if it's something that has a fixed power cord, then a little like plug adapter like this, which are super sketchy, also would do the trick. All right, I have the phone set up here so we can get a camera view of this thing. So I have it plugged into the step up transformer here. And let's open this up. Oh, that's it. Gas plasma. Oh yeah, that looks nice. I mean, obviously it's not even on yet, but check that thing out. Okay, sorry about the glare. I'll just keep this angled off to the side. So looking at the keyboard here, interesting is we actually have a normal US layout. I thought the keyboard would have at least some of the main characters switched around. The only main difference here is we have the big ass enter key, the small backspace key, it looks like a pound symbol up above the 3. So it's possible that whoever manufactured this computer, if it wasn't Schneider themselves, perhaps the only keyboard layout available was just the UK keyboard layout, which I think is what this is. In a typical US keyboard layout, right, Shift 3 would be the hash symbol, or like what we would call the number sign, or even the pound symbol sometimes. But this actually has the UK pound symbol on it. And it looks like the hash symbol is down here next to the space bar. Keyboard feels pretty nice to type on. Computer's in pretty good shape. It's nice and clean. And yep, that's the gas plasma screen. I have no idea if this is the same plasma screen that's in the Samsung computer. We would have to completely disassemble this top panel, plastic housing that is, to see that. And I wonder if it's like in a similar situation where there's like a screw under this sticker here. I don't feel anything. I don't really know how to take this apart, but the service manual does exist. That's better than we had for the Samsung, where we had nothing for that thing. So maybe it actually tells you exactly how to take it apart. All right, well, I guess it's time to power this thing up. So this is all plugged in. Let's turn this on. Okay, nothing happened. I think there's a power switch on the back here. Oh, well, yeah, that would explain why nothing happened there. So let's just turn that off and plug this in again and try number 2. Okay, there we go. Let's try this again. Here we go. Okay, nothing happened. That's fine. Here we go. This thing is going to produce about 240 volts because here in my house, it's about 122 volts, if I recall. So we're going to be getting probably about 244 volts out of this thing, actually, which hopefully is not too high for this thing, since it said it was designed for 100 or 220, which is like the older voltage in Europe. I think most of Europe is now outputting 240-ish volts pretty much everywhere. Okay, well, anyways, that looks great. Let's turn off the light here. I'm looking in the phone screen. That bar you see moving is not there in real life. This obviously has some kind of a refresh rate that is, well, doesn't jive exactly with what the phone is using right now. And the way I stream my phone video into OBS, there is no way for me to adjust that. The phone's probably running at 60 Hertz and this is running slightly off 60 Hertz. So yeah, okay, well, let's just get a little closer. And I know you just have to kind of look through the black bar there. One thing is totally apparent. The screen is working perfectly. There are no missing lines, no dead pixels. It's not super bright. Even in my, even to my eyes, contrast ratio is only okay. Again, ignore this. That's not really there. It all looks like this all the time. And taking a look at what we have here at the top here, it says copyright Interlink Business Networks from Brea, California. And the version of the firmware is 1.29e. Brea, California, that's down in Southern California, so LA area. Licensed to Schneider AG, 640K of RAM. I'm assuming this is a 286 or something like that. CGA adapter passed, real-time clock passed, keyboard test. Floppy drive is installed. Hard drive is obviously not spinning, so that's not working. COM ports and fixed disk failure run setup to verify the hard drive. And I'm pointing to things you can't see. I'm pushing F1, boot error. Okay, so let me grab a boot disk. Actually, let's try to clean the floppy drive first, and we'll see what happens. So I'm just gonna put a little IPA on the cleaning disk here. So there it is. And we'll just get this into here, and we'll get that thing to spin a little bit just to try to clean those heads on there. That's probably good enough. I mean, I can't do much more, right? That's just trying to access the drive there. Now, the big question we have is this a 720K drive or is it a 1.2? I'm kind of feeling like it's probably a 1.2, and that's, or a 1.2, 1.4, high density that is. And that's because this should be a 286, potentially, but maybe not. Let's see. It doesn't seem to be booting. So I'm gonna go off the assumption that this drive does work, but I need to create a 720K boot disk, which I can do. Oh, it looks like I have one right here. It's got a little tape over the thing there, but it's for the Tandy DOS 622. Let's try this one out. Ah, okay. This does not appear to be working either. Why don't we do a Control-Alt-Delete though, just in case. Where is the delete key? There it is. Now, when it comes to the plasma screen on this machine versus the plasma screen on the Samsung, the only way we know if they're even compatible is to open this computer up entirely. One of the things that has me concerned though is that machine was VGA and this machine is CGA, right? So it looks like it's trying to access the hard drive right now. Maybe that's why it wasn't booting as well. Oh, there we go. Okay, F1. See what happens here. Anyhow, so as I was saying, so this is obviously a CGA screen. It's lower resolution, so that may mean that it is completely different and incompatible. But on the other hand, this computer seems to be, I'm just reading, nothing noisy changing here. This computer does seem to be working, and it is smaller than that Samsung, so I don't know if I would ever try to do something like try to salvage this screen. If this computer were like too far gone and not working, or it could never work, then maybe we would try to like combine them together. But I'm not sure that that's probably an appropriate thing to do, as this computer is in pretty nice shape and it is obviously working. Well, okay, like it's kind of working. Obviously the disk is not even accessing anymore. Funny, we don't even have an error, or no, that's it right there, right? Okay, yeah, so, all right, well, no big deal. If we look at the side of this thing here, the floppy drive, which is a little hard to see, is just a standard 3.5-inch drive. So that means that it'd be easy to open this thing up and swap that out with another one. Now, the question is, of course, how hard is it to open this computer? It sounds like a little bit of that was already done to try to get that hard drive working, but maybe it's pretty easy. And then we can just try to swap that thing out as it is. Got some screws here. Well, okay. Why don't we go to the service manual? Okay, a quick Google search took me right to archive.org, and here it is. Let's see what we see. I think this is in both German and English. Oh, portable AT. Yeah, 286. So scrolling through this service manual, it's light. Let's just say there's not a whole lot in there. We can see the parts breakdown there. So that's the panel itself right there, which is number 3. There's some kind of a glass or plexiglass plastic cover that is a part of the bezel here. And I'm going to say, yeah, you take the sticker off and maybe there are a couple screws there to release the entire plastic assembly. Scrolling down, we got hard drive, floppy drive, power supply unit in the back there, and motherboard and keyboard. And then we look down here, yeah, okay, we got some parts list, so crystal oscillators, things like that. Here it is, there's the processor, so we have a 286 at 8 megahertz. And then there we go, we actually have the motherboard layout. One thing we can definitely see is that expansion area with a little cover on the back of the computer is definitely not ISA, because it's probably down in this corner here, and we would have an ISA connector. Oh, I mean, nah, these aren't ISA, right? These are, like, that's not the pin out of ISA. ISA would have 2 rows of pins. This could be like a 16-bit connector, and these are 8-bit, so this is some kind of proprietary thing that probably plugs in. I don't know what those physically look like. Maybe they have like little, like they're raised up pin headers or something, but yeah, this form factor is definitely on the non-standard side. Ah, yes, and look, floppy drive interface, so there must be some additional boards stacked in there. And what's this here? Floppy drive interface again? Oh, hard drive interface. Ah, right, okay. Okay, yeah, this is definitely just using MFM. So it looks like it connects to one of those high density connectors in there. It must be sandwiched in there. We've got some ICs there for the various functions of the MFM or ST506 controller. That's it for the entire manual here. So it doesn't really explain how to take this thing apart, at least not in any procedures. And all we have is this right here, which just shows the breakdown. And it doesn't even show what we have to take off to get things apart. Like, do we need to take the screen off first before we can even remove the top cover? Or do we get the bottom cover off first, or what exactly? So I think the best thing to do here is just start taking screws out of this thing. And I apologize, again, the camera is not very wide angle, so I can't get it all in. I do need to get a new mount for this camera so I can move it up higher. That way I'll get a wider angle just because there's more distance than is available here. So I'm going to start on the bottom here. This is how I did it on the Samsung. I thought maybe some of these screws were long and they go through all the way into the top cover. That one's already missing. You can't see what I'm doing. That one's missing right there. And then there's this one. So we have a total of 4 that were installed on the bottom. All right, so the screws they're loose, but nothing seems to be released in any way. Let's just keep going. I'm just gonna keep removing all the screws I can see until something happens. These screws on the back are a bit larger than you would expect. They look like that, and I think that's because they stick out of the back of this plastic here, and if you rest the computer on its backside here, like if you're holding it with a carry handle, this will be a little like foot, so to speak. All right, well, the back of the computer is loose, so let's see. Does this pop off in any way that makes sense? Don't want to force anything. Looks like someone's been in here already and they cracked the case and they had to glue it. So there's a bit of glue right there. It may not be showing up in the camera. It's a bit too close. What I can tell trying to split this, it looks like the top cover here is held onto the chassis with a screw there and on the other side as well. And it looks like someone has glued the case right there as well. So probably if you try to force this up without taking those screws out, then it actually breaks things like there. So it looks like the bottom cover needs to kind of pull away. So I'm going to turn this down here and I'm going to try to get the bottom cover off somehow. Okay, I managed to free the bottom. So yeah, the trick is you take off the screws on the bottom. I also took off these, they go around the ports. This is what you would screw into, like if you have a connector plugged in. I don't think those have to come off necessarily. The front sort of comes down and then the plastic goes towards the back. That way you can unhook it, and let's get this off. Oh, okay, let me go handheld. So now it looks like the handle itself has these screws right here that go into the metal chassis, so you gotta take those off next. All right, so those are off, which means this bottom cover now should come away. There it is. Nothing much to report, it's just beige. And now we're seeing this metal cover here, which obviously is the motherboard. And now I can take the screws out, which should allow me to remove the top cover. I'm hoping that the screen is attached to the top cover and there's a cable we can disconnect. And it's funny, you know, watching this happen, this is one of the reasons why I'm not a fan of laptops. They're just, a bit of a pain because they're such a jigsaw puzzle for when it comes to assembly, and taking them apart and servicing them is very difficult. And it's one of the reasons why I never really featured laptops on the channel. I'm just not a fan of all this work that has to go into them. Now this one is interesting because of course we're talking commodity parts, like the hard drive is right here, and the floppy drive and everything is just all standard stuff, but it's still assembled in such a jigsaw puzzle way that makes it so difficult to service. All right, well, the top cover, yep, oh yeah, everything's sort of falling apart now. So I'm gonna put this down onto its base. All right, so let's see now how this works. Okay, things are coming apart. The keyboard is sort of attached. Now there's a bunch of ribbon cables I can feel under there. One thing that's 100% for sure is someone's been into this thing before. This is not its first time having been worked on. All right, so keyboard has delicate looking ribbons, which are now disconnected. And now we have the screen. Looks like there's some kind of a connector over here on the side of the machine for the screen. And look, all this work so far, just to try to get the floppy drive out, because that's the main culprit here, just keeping us from even booting this computer. And this is sort of par for the course. Now underneath here, it looks like there's a connector for the screen. So there we go, that is now freed up. It looks like it's keyed, so that's good, so we can't plug it in the wrong way. Don't know why the keyboard is still attached to the top cover though. That's kind of annoying. Let's put this on its side now. And it looks like the keyboard's attached because there's a screw hidden in the middle there. That's such a bad design. Anyhow, there it is. There is the inside of the computer. So that is the MFM hard drive FK309-26 by Fuji Electric Company. So I don't know if that's related to Fuji Heavy Industries, aka like the part owner or the owner for a long time of Subaru, the car company. But yeah, another defunct hard drive manufacturer there. Looks like we have some masking tape holding wires together. What's the deal with this? There are soldered connections under there. Taking a look at the motherboard here, there's the 286 processors under that little metal flap, and Chips and Technology chipset. This is one of the controllers, so to speak. We have the BIOS ROM chips from 1985, Interlink again, Business Network Corporation. That's that company out of California that we saw. And this isn't totally freed up yet. Looks like a cable is still going up to the top cover. I think this is going to be for the plasma here, or you can't really see what I'm doing, can you? That's for the plasma, but I think there's going to be power and data, maybe something like that. I'm not sure. Let's figure out how to free this. Okay, yep, I just sort of pulled on that, and the connector there came out of the power supply, which is this large beastly thing back here. This is the power supply. We'd have to open that up, A, check for leaking caps, but also B, do that conversion to 120 volts. And the connector for the screen is just inside there. It's a Berg type connector, like a 3.5-inch floppy drive style connector. Without a doubt, looking inside here, there is no ISA bus of any kind. I see some kind of connectors in there, but it's definitely non-standard. I took off a couple screws right here, and looks like this is sort of coming out now. And it looks like the one that's on this side over here, should be 2 screws. That one was already missing. So as I said, someone's already been in here. Okay. All right, well, that's the hard drive controller right here, obviously. So we'll just disconnect these cables here. And the floppy drive, as you can see here, connects directly to the motherboard. And all that's left now is the power. Wait, what's happening here? So this looks like it's the power cable for the floppy drive, but I can see there's a connector on the floppy drive right there. Where exactly is that coming from? Let's get this hard drive one off of here. Comes off the cable. It comes off this. I mean, you can just use a normal floppy drive, I think, because it looks like that's a standard connector there, but it's sending power from the motherboard. How rude. All right, the motherboard should come out. I can see the battery right there, so we're gonna need to address that. All right, so this is sliding forward. It still feels like it's attached somehow. There we go, some kind of like a rail system here, I think for the card maybe. All right, there's the motherboard for the Schneider PC, whatever this thing is called here. A little bit of dust. There's that high density connector that I was talking about for whatever this card is. It looks like there is actually a connector right there that was, oh no, that plugs into the screen. So that's the video connector. Ah, yeah, okay. We can kind of get an idea of what the expansion connector looks like. Hopefully that's visible. There it is. It's like a high density looking ISA bus, probably 16-bit. So I'm sure the signaling is all normal, but obviously it's not standard, so we can't just plug something easily into it. So there's a battery, so we're gonna have to replace that. And really, like, what is difficult now is, well, obviously getting this thing into a state where we can use it is not gonna be super easy. Obviously, powering the motherboard would be possible because it's just a Molex connector, and I guess I could plug an external screen into it. But, you know, getting everything reconnected is not gonna be easy. At least these are standard parts. So at the minimum, I'm gonna swap the floppy drive out and we'll put one in there that hopefully is going to work, unlike this one, or maybe I could just test this one externally. And as for the hard drive, it doesn't seem the spindle is even spinning on this, so it's got a bad case of stiction. I think at that point, this drive will never work reliably, but hopefully we can get this thing actually working and then copy data off of it. So the machine is fully apart, and I kind of realized something, that I backed myself into a corner by attacking this machine and taking it apart. Because when the parts are splayed out all over my desk, and there are lots of little parts and many screws and things like that, it kind of means I'm committed to working on this machine. And I don't think I was, well, I was fully intending to do that, and I kind of got ahead of myself with the disassembly process. But it is apart, and I really don't feel like putting it back together to then take it apart again because it's fragile plastic and stuff like that. So I am going to, well, at least try to get this machine up and running, at least to the point where we can get some software booting on it. So the list I've created here of things that need attention, and this is in no particular order. First off, there's the power supply. I want to try to convert that to 120 volts and also check inside for capacitors. Second of all, there's the floppy drive, which obviously isn't working, so I'm going to have to do a swap on that. That should be pretty easy now that the thing is apart like this. We can also try bench testing that particular floppy drive and see what exactly is wrong with it. I never heard it seek at all, and hopefully that means there's not a problem with the disk controller on the computer and it's just a floppy drive problem. Next up is the battery, which is the CMOS battery. It's not the main battery to run this computer because it doesn't have one. I just want to cut that off the board. We'll check to see if it has any voltage and then run a CR2032 to it. And then finally, there's the hard drive that's in here. It's an MFM hard drive, and I noticed that when taking this apart, I did see a little bit of oil on the main motherboard. So I have a feeling that someone in the past has tried to revive this hard drive by adding some oil to it, and it wasn't even spinning up. So probably a little bit of bench testing will be necessary for that, but it's very unlikely this hard drive will ever live again. It probably can be made to work enough to try to get files off it. But as for putting it back in this computer and assembling it, it doesn't really make sense because it's probably just gonna die again, and getting this thing apart is really not that easy. I really wish there was an inexpensive solution for getting something in this machine to get it booting off a hard drive, something like the compact flash card or XT IDE, but without any way to connect to the ISA bus that's on here, or presumably on here, that's really not feasible. There are hard drive emulators, MFM hard drive emulators, that allow you to replace an MFM hard drive, but they're pretty expensive right now. I do have one, and I've shown it on a previous video. The other problem with it though is it's kind of large. I don't think it's really as small as a 3.5-inch drive. It's primarily designed to replace hard drives that are 5.25 inch. And well, as we saw, this is a 3.5-inch drive. So most likely what I'm gonna do with the hard drive, and I guess I'm kind of getting ahead of myself here, is I'm just gonna probably remove her from the system. We can bench test that, and then I'll probably just reassemble the computer without any hard drive in there at all, and it'll be a floppy only machine. Now I have two choices here. I can either just sort of work on this stuff and show little snippets of it and just make this a quick video, or I can do my usual, which is make lengthy in-depth videos on all of this stuff, which is almost certainly what I'm gonna do, right? Like, who are we kidding here? So I think as far as this list goes, first thing I wanna do is let's look at the battery on here and take a closer look at the motherboard, because I think there's some interesting things about this motherboard that are kind of curiosities. So taking a look at this motherboard, there's a couple interesting observations. First off is I could have sworn when we looked in the service manual, it talked about the fact that there was a hard drive controller PCB on here. That's clearly not the case, because this hard drive cable here actually connects directly to the motherboard. And weirdly enough, this one, which is for data coming from the hard drive, that goes to this small PCB, which does connect to the motherboard right here with that small connector. And it does have one IC on it and probably a couple of passive components. So clearly part of the hard drive controller, the majority of it, is actually built onto this motherboard. In addition, I thought we saw that there was a floppy drive controller as well, but the floppy drive controller is clearly built into the motherboard as well. This one here is probably some kind of a video card, or at least it is logic that takes the video card signaling, which is probably generated on the motherboard, because here's the CGA connector, and then it converts it to the signal that is used by the gas plasma screen. And that is the board right there that does the gas plasma conversion. And look at that, it's got a Yamaha chip on it, which is pretty curious. My only assumption is that this board is replaceable like this because there probably were options for this motherboard to be used with LCD screens, and you would just have to swap out this board right here, and then the output signals would go to the different screen type. So that allowed some kind of modularity. Meanwhile, there would just be CGA output on this thing all the time. In addition, if we take a look over here, we can see that this motherboard was made in Japan, and there's the manufacturer right there, Oki. And it's the OM-2 motherboard. And I'm assuming that this was used in all sorts of other systems. But that pretty much confirms that this whole computer was OEM'd by Oki or Oki Data. And well, there's probably a bunch of other companies out there that were selling the same exact motherboard. IPU 4005-1388A, not sure what that means. I did notice that this board here also has an IPU number on it as well. It is curious looking over here that there is space for a math coprocessor, but the socket is not even populated. So I guess that was just an extra option that they did not choose to keep. Looking at the underside again, we can see here is the ISA bus, or probably the ISA bus expansion connector. It's funny that they kept two of them there to kind of replicate the entire 16-bit thing, so 8-bit versus 16-bit. It's quite possible that Oki Data had previous machines that only had 8-bit, and maybe to maintain kind of compatibility with those expansion modules, they kept this separate. That way the 16-bit extensions were right there. But you can see that that's some kind of a high-density connector, so not easily connected to. The interesting thing about the power connector being a standard Molex connector is perhaps we could just use any old power supply with the 5 and 12 volts to power this up. All I would need to do is just verify that the voltages coming out of the power supply that went into this connector are the same as, for instance, the ones that went to the hard drive. That shouldn't be too hard. If we take a look, that's the motherboard connector, and well, this mess here, which again is hard to believe that this was actually somehow what they wanted to put in a production machine. I'm quite frankly shocked by this. This is pretty terrible, to be honest. Thinking about this a little bit more, this absolutely just must have been an aftermarket mod that some owner of this machine did after the fact. Maybe they tried swapping in a different floppy drive and this was their solution. The fact that this tape is so crusty though means that this was done a long time ago. I'd love to hear your thoughts about this shoddy work in the comment section, so yeah, let me know about that. Now back to using a Molex connector here to power up the power supply, just verifying that the colors match, so the orange is the same as the yellow wire, which is 12 volts on a standard Molex. And let's just double check that everything is actually connected up in parallel between these two connectors. So that is good. And the 5 volts goes through as well. And let's just double check the 2 grounds. Yep, okay, everything is pretty standard there. That means I don't need to use this power supply for bench testing the motherboard, which is actually very handy. Speaking of the power supply, it's another Japanese product here from Tomura Corporation, 1988, 27th week. And you might be wondering why this part is exposed right here. It's probably for ventilation. Those holes in the PCB there allow air to flow through through these holes along the top. And then there is a cooling fan there on the back, which is rather dusty. Let's give this battery a little poke here, see if there is any voltage left in it. 1.7896 volts. Now the thing is, this is a NiCad battery. I can see that it says NiCad on the side, which frankly means we are very lucky, because there you go. You can see it says NiCad. So many of these have spilled their guts, and yet this one appears to have absolutely no signs of corrosion. Oh, maybe, nope, looks like none at all. Let's get this off the board. Yeah, I think that is the epitome of dodging a bullet, but I guess Yuasa makes really reliable NiCad batteries, unlike, well, the Vartas that have destroyed so many things. It's a MIMO-powered sealed NiCad battery made in Japan. Now, as far as replacing this with a CR2032, it goes without saying that the NiCad battery is rechargeable, so we can't just get a CR2032 across these two wires. I'm going to have to add a diode in line. I'll add a Schottky diode just to ensure that the battery does not get charged when this board is powered up, because this will probably just put 5 volts across this terminal while the system is powered. I'm looking around for the clock chip. Don't immediately see it, but you can see some of that oil that I was talking about that has dripped out of the hard drive, which was, I'm assuming, someone's attempt to try to rejuvenate the drive. I can't immediately find a clock chip on this board. There is the 32 kilohertz oscillator right there, and maybe the clock chip is actually contained inside this chipset chip here. This is Chips and Technology PC something or other. Doesn't really matter. I just was curious to see where it was on the board. For figuring out how to connect the diode up to the battery holder, and I have a battery installed in there right now, if we check the terminals here with the battery installed, we get 3.30 volts, and we're gonna get that right here to this side of the diode. And if we check the other side of the diode, there we go, about 3.2, 3.18 volts. If you had the diode reversed, then what would happen is you would actually get nothing. So really the correct orientation is using the Schottky diode. You want to connect the side without the band. The black mark is the band on this one. You would connect the side without the band to the positive terminal on the battery holder. And then you want to make sure you use heat shrink to cover that all up, and then you can attach some wires. And there we have it. I grabbed some excess wires I had just laying around, and I've soldered them onto the motherboard, and I cut the battery off, leaving those headers or leaving those pins there, which is actually perfect because I knew I was going to be soldering wires to that. And with a little heat shrink, this is actually a stronger connection, I feel at least, than if I had removed those pins and installed those directly into the motherboard. And I put a little hot glue on the back of this. Probably what I'll do once this thing is back together is I'll use a little Velcro on the back of this, or hook and loop as it's actually called, and I'll probably just stick this in here. So if you need to change the battery with the computer assembled, you just remove this little cover here, and then you can pull this out. There's enough length, and then you can just pop the battery in, which I'll just do like that. And there we go. Now there's a clock battery on this machine. Before we move on to bench testing this with an external power supply, I'm noticing that the layout of the motherboard here doesn't match what's in the service manual. And I have the motherboard in the same orientation as the service manual diagram here. And you can see this notch down here in the corner is the expansion header there, or expansion area. Now a good amount of what we're looking at here looks similar. So that's the CPU right there. There's the math coprocessor. But then notice there are several ICs that are in the same orientation as a math coprocessor, and that's not at all what's actually on this board here. That does not match. Now up here where the two EEPROMs are, there's a big blank space there in the service manual, and yet on this motherboard there are actually a couple ICs there. And just the general layout of all the ICs there look different. And the same up here. So this is the speaker, and there is a keyboard connection. That looks the same. But then these two ICs and these ICs are all just in slightly different positions. On top of that, underneath this little board here, which plugs into the hard drive, on this board there's a large PLCC, yet on the schematics it shows a bunch of 40-pin dips. And finally, the big change I notice here is in the corner, it looks like there's some kind of a round coin cell that is possible on this board, but on the actual board here, we have a large PLCC as well. So obviously, we're talking about a different motherboard here than we have in the service manual, which, well, it's kind of unfortunate. It's a good thing this computer does appear to be working properly, because that means that trying to fix this thing is going to be a lot harder than if we had the actual schematics for this revision of this board. Probably explains why over here we have the floppy drive interface, which is integrated onto this motherboard. And there's also this hard drive interface board, which also is integrated onto the motherboard, like this large PLCC chip, which we clearly don't have on a separate PCB on this particular computer. And really the main reason why I wanted to talk about this is because there's at least two versions of this machine out there. And if you're trying to service one that's not working, just know the service manual that does exist out there may not be the right one for your machine. Let's break out the power supply here. So this is my bench power supply. We're just going to use the Molex connector on it to power up this motherboard. And a final sanity check before I actually power this up is I just want to make sure that the 5 volts from the Molex connector on the power supply does make its way to the 5 volt chips on the motherboard. These TTL chips are easy to figure out which is the 5 volt pin. And it should be this pin right here on the 74LS chip. And it is indeed, which is perfect. I just wanted to make sure that the 12 volts wasn't swapped around on here or something else that's weird that could result in 12 volts making its way into the motherboard. Let's switch over to the ground pin and just make sure we have ground where we expect it. And we do indeed. Okay, perfect. So I have the RGB to HDMI on the other end of this cable here. So let's just plug this in here to the video output. And hopefully this machine is okay running without the screen connected. And obviously I don't have the keyboard connected either, at least at this time. On the RGB to HDMI, I'm just gonna set this to IBM PC compatible and we'll try CGA new. And let's just power this up and hope we don't let the magic smoke out. Oh, okay, they just got a beep out of the computer. So that implies it was just doing the memory check, but I guess it's not outputting any video right now. Maybe there's a key combination or actually a setting in the BIOS to tell it to use the external monitor. What I was actually hoping would happen is that we would actually get a video output on this thing, and then I could just grab the keyboard and plug that back into the motherboard so that we could actually test out the hard drive and a different floppy drive on this machine. Doesn't seem like that's gonna work for us. So I think I'm gonna change tactic here. I'm gonna grab a different motherboard and then we can bench test those two peripherals. Taking a look at the disk drive here, we have a Toshiba disk drive, which makes sense. This thing seems to have all Japanese parts in it. Let's pop the cover off this drive and see if we can see anything that's obviously wrong on the inside. So far, so good. It looks pretty clean in here, which doesn't surprise me at all. Does this thing turn? Yes, it does indeed. This particular drive does not have the surface mount caps that seem to go bad so frequently. It's got these electrolytics connected up here, so I don't think that's the problem necessarily. And taking a look on the inside here at the micro switches that are inside this drive, this appears to be a 720K drive only. I just grabbed another random floppy drive that I had sitting there, and if we flip this down, I can see there's a micro switch over here on this side, and there's a micro switch over on this side. But the drive that was in the laptop only has a micro switch over here on the left side, which if you take a look at a floppy disk, that is the Write Protect one over on the left, and this one would be high density, and this is a double density disk, so that doesn't use that. But that definitely confirms that this is a 720K drive. 1.44 meg drive, whoever makes this thing will make a good fit for this thing. Ah, there we go, it's a TAC drive. Those are generally very reliable. I guess the only problem we might run into is the power connector is over here on this side. I just need to figure out where pin 1 is. Pin 1 is right there, which might present a little bit of a problem simply because this cable I don't think is going to reach. Instead of trying to extend this little wire here, I'm just gonna try to find a different floppy drive. I was about to plug this Toshiba disk drive that came out of the laptop into my Pentium test bench here, and I did go to double check. The drive select jumper was set to drive select 1. It's actually set to drive select 0. I know it says 1 there, but it normally is 0, 1, 2, 3, and this one just happens to be 1, 2, 3, 4. So that means the drive I put into that computer needs to also be able to be set to drive select 0. And for 3.5-inch hard drives, that's not always super common. Case in point, this Neutronix drive here, where the cable does fit on there, doesn't actually have any drive select jumpers, well, at all. Removing the bottom cover of the new drive does indicate that it does support drive select, but it's a surface mount resistor. So to get this drive working on the laptop, I'd have to move this over to DS0. And before we do that, I will bench test this because the drive is a little old looking, so I want to make sure that this works before I assemble it into there. So let's just hook up both these drives to this PC so we can bench test both at the same time. So I set the Toshiba drive to drive select 1, so both of these are on drive select 1 now, and that's how you have to do it if you're going to hook it up to a PC, because the twist is what takes care of the drive select on a regular PC disk drive. All right, everything here is all ready for testing, at least for the floppy drive. Let's power this thing on. Let's just quickly set this up for the two drives. This is 720K. And yes, I'm running my test bench here through CGA, just so we know that the RGB to HDMI was working, since we didn't see any picture when we powered up the laptop motherboard on the bench there. So I have a boot disk in here right now in the A drive that I took off the pile, the one I'm gonna put in the laptop, and it's booting. As you can see there, we're actually booted off a 1.44 meg disk. Let's pop a 720K disk into the floppy drive here, into the 720K drive. Nope, that's not reading that disk. Now, this is actually a 1.44 meg disk with tape over the hole, so it's formatted as 720K. And you know what? Now that I think about it, I've had problems before with true 720K drives like this one not being able to successfully read 1.44 meg disks if you have tape over the hole. So I have that 720K, well, virtual 720K disk here in the A drive now. And if we type dir, okay, so yeah, it is readable, but I don't want to rule out this 720K drive yet to be totally not working. So yep, it's definitely not working, but that could well be because I need to use an actual 720K disk. So I ran and rebooted the computer, booted off the compact flash card now, and this is a true 720K disk here. I'm gonna put this into the 1.44 meg drive here, and I will format it as 720K, and that of course is in the A drive here, the drive I know works. All right, there we go. That disk successfully formatted. Let's just copy a few files onto it. Let's sys that disk first. It is in the A drive, the one we just formatted. That's going to copy the MS-DOS 622 system onto it. And let's see if this 720K drive can read an actual true double density disk. And it can. Look at that. I've gone over to check it here, and let's do a diagnostic on the B drive here. And this will allow it to kind of do a random seek test and also check all the sectors on this disk just to make sure that it's really reading it properly. I'm gonna skip the write test though, since we just formatted that disk and we know it's good. Well, this tells us really one of two things. Either the computer disk controller has a problem, or maybe the power supply so the drive wasn't getting the right voltage or something. But more likely what happened when we tried to boot this computer was that I tried to use a disk just like this, a high density disk with this taped over, and the drive was not able to read it. What's fascinating to me is I have used these types of disks in so many other computers, including 720K drives, and it works. But I have run into a situation one other time, and I think it was also a Japanese 720K disk drive in a laptop that could not read these types of disks. And the funny thing is, I knew the drive in that computer was working because I had one of the original system disks with it, and it booted and read that disk perfectly. But when I put one of my disks in with the tape over the hole here, it didn't work. Well, then I knew that maybe that was the problem. But in the case of this machine, I just wasn't sure the drive was even working. I didn't hear any noises to indicate that it was seeking even. So I just sort of jumped right to the idea that it was bad. As you can see with the output of check it right here, everything worked on this disk drive. So this 720K drive does actually work perfectly. Now that's not to say that I am not gonna still swap these drives, because I absolutely am. I would rather have this 1.44 meg drive in that computer, because remember, this computer is not likely to have a hard drive in it anymore. It's only going to have a floppy drive. So you'd probably rather have additional capacity of the larger drive than have this original 720K drive. So that just means to use this drive in that computer, we're just going to have to move this 100 ohm resistor here over to DS0, and then it should be fully compatible. So resistor has been removed. I'm just going to pop it into the other position here. There we go. It's not exactly centered, but that should work. And I'm just going to pop this bottom cover back on so this thing is fully protected. And the one last thing I just do want to compare is the size of these drives, just to make sure the new drive is going to fit in there. And yeah, it's going to work. It's exactly the same size. All right, next up, we're going to turn our attention to this hard drive. I'm going to power this up from the bench power supply here, which is obviously going to be almost certainly a more beefy power supply than the one that was on the laptop. And maybe that'll actually get this thing to spin. Let's see what happens. I heard a click out of it, but that's it. Now underneath this little cap here, this is a grounding strap, is the bearing of the spindle motor. And if we take a look under the PCB here, this is almost certainly the spindle there. Let's see if I can move it. I can move it. Let's turn the power supply on now that I moved it. Nope, nothing. If we power on the drive here, there we go. There we go. Wow, it sounds like it's working actually. So let's power this off and on again. Did sound like it was seeking properly. Ah, look, it didn't even spin back up again. It's almost like it's given up already. Let's turn the power off, turn it on, and then I'll give it some help. There we go. Yeah, wow. Yeah, that's just a sticky bearing. Probably worn out, unfortunately, just from age and use. And this thing was never designed to work that long. One thing I can do though is I can just let this run. So I'm just gonna flip this over to its normal orientation here. And I'm just gonna let this run for like, I don't know, we'll just leave it on for an hour, let this thing heat up, kind of like loosen any of that sticky grease that might be in there. And then I guess what I can do is grab a hard drive controller and we'll hook it up to the test bench here and we'll see if we can read this thing. Okay, well, that escalated quickly. Unfortunately, the drive does not work. Now, I did record the footage of me taking it apart. Well, I thought I recorded it, but I didn't. I actually forgot to hit record. So yeah, after I let the drive run for a while, it got a lot of heat in it. It still did not work. It would come to a stop, and that was that. So I decided that there was no way the drive was ever going to work again because there was something mechanically wrong on the inside. And sure enough, I took it apart and I confirmed the problem. So there's a bunch of fingerprints on this disc right here, but that right there is not a fingerprint. That was there. And that was where the head, and it was the, well, not the very bottom head, which was on the underside of the bottom disc. It was the one on the top side of the bottom disc, got stuck right there. And I guess that's where the heads park when the drive stops, and it comes to a stop and it stops right in that spot. And anytime the disc tried to move past that spot there, it was not happy. And look at that, actually, it wiped away. But yeah, before I touched this disc, I had the top disc off, and that mark was visible. So I'm pretty sure there was like moisture in the drive or who knows what. And the heads, unfortunately, just got stuck on the disc, which means that there was no way this drive was ever going to work again. And I guess we're just gonna have to go with no disc in this machine. You know what, while I'm thinking about it, this is the MFM hard drive emulator I was talking about. So yeah, this is too big to fit inside this computer, even if I had a spare one of these. This one is destined to go into another machine that's much more rare and also only supports MFM or ST506 type hard drives. But there's the URL right there, ptp8online.com/MFM. This is a Rev C, and it does have some super caps on here. And the reason for that is because this board here, this is a BeagleBone, it tries to run once you power down the computer so that it can make sure to save any kind of cache data or whatever on there. This does run Linux, so there's a console and, you know, MMC storage and stuff like that. But yep, this is a pretty good solution. And it also allows you to plug an MFM hard drive into it and archive what's on that drive, read it into this thing for archival purposes. Since Peter had indicated that this particular drive that was in this machine, well, we already had a copy of the utilities for this machine, we didn't necessarily need to try to recover it. But the fact is there was that physical defect right there on the disk that was kind of keeping it from spinning properly. I have a feeling it would never have worked properly because we'd have like tons of bad sectors on that particular platter at least. And that just means reading files off there is a long endeavor and not likely to result in any usable data. Okay, so let's think about our list here. We have the battery sorted, we have a working floppy drive now, well we always did, but now we have a working high density floppy drive. A hard drive we know is totally dead, and all that we have left is the power supply. So I might as well just grab that and let's take a look inside, see if we can convert that to 110 volts, and also I'm gonna look for any leaky caps. All right, first step, extricating the power supply from the metal chassis here. Now, power supplies inside computers like Toshiba laptops are absolutely notorious for dumping their caps all over the place. So your mileage may vary. Some are gonna be fine and others aren't. Hopefully this power supply is fine. And yep, so far, so good. What we're looking at on this side is the high voltage input side. So there's the primary fuse. We have inductors and MOVs, stuff like that. There's a bridge rectifier right here, which converts the AC into DC, and then that goes into this large cap. And then there's a chopper transistor, which will be this right here. And there's a controller on this board somewhere. And that's what creates the high frequency AC, which then goes to the transformer, that gets rectified back to DC again, and then it goes through these filter caps and then comes out of the power supply. Looks like we have a voltage regulator right there for controlling probably the 5 volt or maybe the 12 volt rail. Depends on how the feedback circuit works exactly. Now, the problem is, looking over here on the high voltage side, is I was hoping there would be 2 filter caps, because when there is, there's usually an easy way to convert from 220 volt operation all the way down to 120 volt operation. And that involves just adding an extra wire from the bridge rectifier to in between the 2 caps. That is not the case on this one though. So either this power supply already can work down to say 100 volts like in Japan, or it really is only rated for 220 volts. Now what I didn't go do is look up this part number here, because maybe this particular power supply is in use elsewhere and we can find out a little bit more about it. Yeah, okay, I just did some searching, and really, this part number here seems to link back to Oki data stuff. Doesn't really go back to anything from Tamura, and I can't figure out, you know, voltages or whatever. If this were just standard 5 volt, 12 volt, easy peasy, there would be no issues. But I'm pretty sure that the voltages that come out of that connector that go to the screen are going to be like 200 volts or so. Now I might still try to convert this power supply over to 120 volts by removing this capacitor and trying to bodge in 2 caps in here and running the wire on the underside to the bridge rectifier. Problem is there's just not a lot of space in here. This area right here is used up by the IEC input and the switch, and then the wire that goes to the mains here is kind of in this area as well. And then this spot right here is exactly where the fan goes, so I can't put something in there. As far as the output of this jack right here, we can get an indication of how high the voltage is by the fact that this capacitor right next to it is 250 volts, which kind of indicates that, yeah, this is the cap for that, and it's high voltage, so probably 205 volts again, similar to what it was on the Samsung computer. The rest of these caps, you notice, are like 10 volts, things like that. There should be 10 or 16 for the 5 volts or 12 volts that come out of these connections. And this high voltage here for the screen is not just connected up to the AC mains on the other side. This is generated by the switch mode power supply here. There's just a winding available on this transformer, which is just much higher voltage than it is for these other rails right here. So this transformer is designed to be used in a power supply like this that has a 5 volt, a 12 volt, and then it has a 205 volt or thereabouts rail. And on the underside, there are no silkscreen markings, so that gives us no clues to the input voltage range or the output voltages. Well, I just spent a little bit of time looking through various caps that I had here, trying to find, I don't know, 2 caps that added up to the same capacitance of this in the 220 volt range, because you really want to use 2 220 volt caps in place of this 440 volt cap. And I really don't have the right parts in stock, especially anything that might even fit in this small space. So I think this is pretty much a lost cause, and I'm just going to have to run this power supply with the step-up transformer anytime I go to use this thing. There's also the possibility this power supply can work at 120 volts, but I just don't know enough about switch mode power supplies to know if that is going to damage anything for me to even try that. One last thing I just want to mention is that if there were leaky caps over here in the output stage, we would see that on the bottom. There would be like goop and stuff, and there is nothing. Everything looks really good on this board. So I'm just going to reassemble this thing since this power supply appears to be working properly. Power supply is back in the frame. I think I'm just going to try to assemble the computer loosely so we can at least test it out. Oh, actually, you know what? I'm just going to fix this garbage first. I'm going to take this extra burr connector off and use heat shrink to reattach these wires. I'm noticing how this was done. They scraped away the insulation and soldered right to it. Wow, this is sketch, very sketch. There we go, that connector's been removed, and I guess I'm just gonna cut these wires and then I'll resolder them, and I'll use heat shrink to fix this problem that was created. Alrighty, wires are all soldered together, and I actually took the opportunity to sort of partially reassemble the computer. Working on this computer reminds me, and I kind of mentioned this already in this video, why I really am not a fan of laptops. I mean, I'm a fan of the outcome of them, but working on them is just such a pain. This thing is like a jigsaw puzzle, and in fact, getting it back together, well, I've had to take it half apart and put it back together multiple times just because of the way the motherboard goes in and the bracket on the back here with the ports there. It just, all of it is extremely frustrating. It's pretty funny too. I actually fixed this connector here, and well, there's not going to be a hard drive in this thing either. But nonetheless, the computer is assembled enough. There's no bottom cover, no top cover, but I think we can actually place the top cover on this, connect up the screen to the side here and the power over here on the left, and then the keyboard there. And I think we can actually test this thing out. All right, well, everything is reconnected to this thing. The bottom cover's not on. And what's also hilarious is I have all of these screws here, which I've taken out of this computer and are not back in it. And I think I have all the screws in, except the top cover is not screwed down, of course, or the bottom cover, but That seems like more screws than are necessary. All right, well anyhow, it's a moment of truth here. Let's turn on the step-up transformer. Okay, nothing happened. Let's turn on the power supply. Oh, what's happening? All right, well, we have stuff on screen, but it's in 40 columns. Why? I wonder if the battery had actually been holding a charge that, oh yeah, I suppose setup will have been run. Oh no, and it says floppy drive A failure as well. No, you gotta be kidding me. So obviously pushing F1 doesn't do anything. The drive is not even trying to boot right now. Let's see if the keyboard is even working. The keyboard doesn't seem to be working at all. I plugged in the keyboard cables here. It's very difficult because you have to do it all with your fingers stuck in there. They came out. So that's why the keyboard wasn't working. But before I try to reconnect that, I might as well try to figure out what the heck is going wrong with the floppy drive. The one we tested and we know works doesn't work on this thing. Well, I was able to flip the cover up and I see the floppy cable is definitely connected correctly. Pin 1 is over on the right side. I see 40 on the motherboard there. It is on the connector correctly. The power cable was attached to the drive. All right, just for testing, I've swapped the cable around so the pin 1 is towards me now on the edge of the drive. And let's take a look at the LED there when we turn this on. Well, that didn't turn on the light either. Let's see if the drive is powered up. Not sure about that. Yep, drive is definitely powered up. Oh, look at that. I know there's a rolling bar, but it doesn't say floppy drive failure. All right, it says floppy disk pass, 1 drive installed. All right, next step is to pause the camera so I can fix the bar. It looks like it's not doing it right now, but I'm gonna lock the frame rate so it won't do it, and then we will stick a boot disk in here, hook the keyboard up, and see if this thing freaking boots. Well, we're still dead here. So obviously you can see the keyboard is working. I can hit Control Delete, but the problem is right now is that while it says the floppy drive is good, it doesn't actually work. I put a disk in there, the light doesn't even do anything. If we hit F1, the light down here blinks really quickly, but the light on the drive does not. So I'm wondering if this uses some kind of a way to detect if a disk is in the drive, and right now it's not detecting a disk because of, you know, whatever, the signaling is a little bit different on this standard PC drive that I put in versus the original drive. That means, unfortunately, the only thing I have left I could try here is to hook the original drive back in this computer and see if that works, which involves taking it apart again. And yeah, I don't think I'm gonna film that because there's gonna be a lot of cursing, so I'm just gonna do a jump cut. There we are, things back together. I've swapped the floppy drive and we have what seems like the first progress that we've had since I've started using this machine. We are actually booted up into MS-DOS 622. Now we're using that disk that I formatted on the test bench computer, so it doesn't have any utilities on it, but command com, but the machine does boot. It does appear to be working. That is a massive step forward. I'm gonna go download those utilities for this machine and put a couple other DOS utilities on here so that we can actually get this thing configured. All right, I've gone full on moody with the light off here, so I have utilities. I think the right ones copied onto that disk. Let's power on the computer here and hopefully we can run setup. What I ended up copying on this disk was the mode command, that's just from MS-DOS 622, but also speed 600, along with a plasma command, monitor command, and a palette command, which I think are very similar to what we saw on the Samsung S5200. I'm just looking at my camera screen, making sure the plasma looks good, and yeah, it does look okay. So here's a setup utility. It was on a MS-DOS 3.2 or 3.3 floppy. Hopefully this is set up. Yes, it is. It's looking not great. Video display says 80 columns. Let's see if we can exit out of here. Let's do mode CO80 first. That will switch us into 80 columns mode because it seems the setup utility didn't actually do that. Now, speaking of the Samsung computer, it did have like a brightness and contrast control. This one doesn't seem to have either of those. So my assumption is this is just a fixed value that we have here on the screen. I haven't seen any other controls. Oh yeah, okay, this looks good. Does this even show up in the camera? Whoa, okay, I hit enter and it rebooted, which I'm assuming was the save command. I was just trying to see what other options were available, there. But hey, look, we're in 80 columns mode at least now. And the battery is connected, the one I added, the CR2032. So hopefully this thing actually, well, will retain those settings. We don't know for sure. What's happening now is the computer's just sitting here and it's not doing anything. I don't know if it's like trying to talk to the hard drive, but the light's not on. Why don't we do Control-Alt-Delete? All right, well, maybe we just need to wait a little while. So let's just talk about this plasma screen. Now, back in the day, I remember working in a computer store. This would be around 1991. I remember people bringing in these types of computers. I mean, not this Schneider one, but, you know, Toshiba's or whatever that had these plasma screens. And I remember being quite enamored with them, thinking they looked really nice, especially compared to LCDs on other portables. But I really don't remember them being this dim. That's the thing that's a bit surprising to me, is both the S5200 with what we could see on it, and then this one, it just doesn't seem like there's a whole lot of brightness available to the screen here. Now, it's really worrisome that it's just sitting here like this. I don't know what option I set that might have caused this, but the only thing I can think to do here is turn this off and take the battery out. And I'm really, really glad the battery is right here. So I can very easily just pop the battery out right here. There we go. And there's probably some amount of time we have to wait while the battery's out before it loses its settings. But let's see, maybe it already lost the settings that quickly. Nope. All right, well, I think I'm just gonna power this off. I'm gonna let it sit. Hopefully the settings go away. And then when I fire it back up, we'll be in 40 columns mode again. And then we should be able to get into setup and I will disable the hard drive altogether. It's actually the next day now, and we've made a little bit of progress. Taking the battery out after, I don't know, a while, that did work, and it went back to that 40 column mode. So I was able to boot the floppy disk here and do a new setup, and I made sure there was nothing invalid in there, because I think there was like a bunch of invalid stuff, which is probably why it was hanging. After doing that setup, I put the battery back in, and I think the machine hopefully should have retained its settings and actually work. Yep, so we're in 80 columns here, and that's it, it's booting. All right, it works. We are booted up into MS-DOS 622, and those are the various programs on this computer. Let's run speed 600. There it is, landmark speed test. See how fast this computer shows up. As well, that is completely unreadable. Looks like there's some kind of patterns going on here. I don't even know if that's going to be visible because of the focus. This is very similar to the Samsung S5200 with that palette program that allow you to pick different patterns and stuff like that. So let's go do that. All right, I think this program looks very similar. These different colors, which it's all in German, are actually patterned. I think this plasma screen can only show basically black, white, and maybe two shades, and maybe even one shade. So to simulate these various colors here, it's using patterns as opposed to shades. So it looks like you press page up or page down to alter the pattern that's visible for each color. And you know what, to be honest, this thing doesn't support any shade. I'm thinking that this thing is strictly monochrome, because rotating through these colors here, using page up and page down, all I'm seeing are various patterns, and that is it. The last program on the disk I copied was something called Monitor, which made the screen blank out. I am assuming now we are looking at the output on the external port there, and I bet you if I type plasma, probably comes back. Let's see. Yep, that's exactly what that does. So monitor switches to the external output, plasma internal, and it seems like there is no other way to do that. So to use your external monitor, you literally have to run a program from DOS. There's no key combo, at least none that I know of. So here we are back in the setup program, and I've figured out how to use this thing. You have to push page up and page down on these options. I do have drive A set to 1.44, which I realized is actually wrong, since this is actually just a 720K. And for hard drive types, there's just the standard stuff here, and there is no custom type, so there's no way to type anything in. Hitting enter on the keyboard will reboot the computer and save those settings, and look what happened. It just went back to 40 columns mode here, because I think it's actually looking for a monochrome video adapter, which is definitely not installed in this. And look, it's complaining now about system options not set. Now, people might be curious if a double floppy drive installation in this thing would be possible, because that would be a pretty nice upgrade, especially if we could use, well, something like a 1.44 meg drive. But yeah, we kind of figured out that that is not possible. Unfortunately, that is not going to be the case. And that's because if you look at the plastic here, it actually has a notch cut out for where the floppy drive sticks out of the case. But looking over on this side, while the chassis has a cutout for where a floppy drive could stick through, and I think it would actually mount up to the bracket without any issue, the top cover unfortunately does not have that notch cut out in it. The bottom cover also has a cutout here that's required for the floppy drive, but you can see on the other side there is no such cutout. So I think at this point, all that's left to do with this machine is put it back together because it's, well, done. As done as I can get it. Well, there we have it. The machine is all back together, and I figured out a couple interesting things. So let's power this thing up. While it boots up, let's just summarize a few things about, well, what I went through with this machine. We can look at the aftermath of the disassembly of this machine. So we have the hard drive here that was unfortunately had stuck heads and was never going to work properly. So that's been removed from the machine. I have this extra floppy drive cable or whatever this is that I removed from the computer as well. We have an original NiCad battery, a Yuasa brand one that did not leak. And we have actually just a few screws once I was all done with the reassembly. I think mainly the screws that were left were what were used to mount the hard drive into the machine. The fact that the step-up transformer is still sitting here on the desk, of course, means that I was not able to modify the power supply to operate 120 volts. And I just don't know if it's going to work if I plug it in. And I'm kind of afraid to just try it on 120 volts in case it does somehow get damaged. I wouldn't want to have gone through everything I went through with this computer so far just to have it not work any longer. But there is the machine. It's all booted up and it is totally working now. Well, it's working as well as it can possibly work. Now with this computer booted up, I want to show an interesting thing that I've actually figured out. If you hit Control-Alt and I press the End key, the screen turns off and you can see that the display is now output from the CGA output on the back, which I have plugged into the RGB HDMI, and we're looking at the output of that through OBS. I found that hotkey combination by just basically hitting Control-Alt and pretty much all the keys on the keyboard until something happened, and it seems that End is the one that switches to the external output and Home is the one that switches back to the internal screen, so Control-Alt Home, and there it is back on the plasma screen. Unfortunately, that key combination only works once the system starts to boot. So the original BIOS screen that you can see the output of the diagnostic information, that is always going to happen on the plasma screen no matter what. I suppose one thing we might try is hit Control-Alt-N. So there we are looking at the CGA. And if we now reboot the computer, maybe it'll actually stay. Nope, it went right back to the plasma screen. I figured while we have it hooked up to CGA and we're actually capturing the video, let's take a look at how fast this computer is with the landmark speed test. I know it's a terrible benchmark, but I find it useful just for comparing, well, apples to apples. So if you're going to run this on your 286 laptop or desktop computer, you can kind of get an idea of how fast just the CPU portion is compared to the other systems. So we can see here that we're running at an 8 megahertz clock speed, and the CPU effective speed is around 9 megahertz, which usually has more to do with like wait states and other efficiencies within the chipset. If you have a 0 wait state IBM PC AT, an 8 megahertz system is actually running more like 10 or 11 megahertz, at least off the top of my head. But from my recollection, if you're running this particular utility on an actual 8 megahertz 5170, you know, the original 286 machine, it's gonna show a CPU performance of around 8 megahertz as well. I'm going to use Jim Leonard's ROM dumper utility here just to dump the ROMs on this computer. They should be saved to the floppy disk here. And that, I'm just making sure that it's able to save. Yep, that's just going to save the BIOS off this machine. When poking around the files that Peter had on archive.org, it looked like some BIOS images were up there for this machine. I'm just not sure if this particular version is up there. So I will upload these files to archive.org just in case, well, just to preserve this particular version. And I made another disk here that actually has a couple games on it just to show that this thing can actually run games. Now it has a weird idiosyncrasy, this computer. Now I just switched the floppy disk, but if I type dir, for whatever reason, it usually, oh, that actually worked. Sometimes when you switch the disk, it actually just thinks the original disk is still in the machine, like it didn't detect that any kind of disk change happened. Let's just confirm that by swapping back to the boot disk here. And now if we type dir, what are we going to see? Yep, so that did not detect that the disk changed. So I'm not quite sure what's going on with that. That might be a DOS 622 idiosyncrasy, or perhaps if you run the original operating system this computer came with, which was, I think, DOS 3.3, maybe those things will work. But a way around there is you can just hit the B:, and what that'll do is it sort of simulates a second disk drive, but it's really just on the main drive, and that will see a disk change. So let's run the game Arkanoid 2, which is a good game that's like contemporary. You can see the date there, 1988, which is basically when this computer came out. Now, one of the things I've noticed about this computer, by the way, is while some games are running, they take full control of the keyboard handler, I guess, and that Control, Alt, End, and Home to switch displays does not work. So right now we're going to be looking at the game running on CGA here, which obviously looks like it looks because it's CGA. And let's see, yep, animation is good. It's working well. I mean, it looks as good as a 4-color CGA can possibly look. And using this game with the keyboard is not ideal. You'd rather use the mouse, right? Oh boy, here we go. Keep some of those balls going. Now, as I said, yeah, Control, Alt, End, and Home, they don't have any effect whatsoever. Now, you can exit this game by hitting F10, and then I think we can switch back and forth. Yes, we can. And now if we go back into Arkanoid using the internal screen, things look, well, a lot better because this particular panel is just forgiving for those 4 colors. It looks okay, to be honest. It's using those patterns, right? Because it doesn't even support any shades of orange. Let's go into the game. Now, one of the issues is this game has a busy background, but you can see there, it's okay. It just, well, the problem is hard to see the ball on this like busy background here, and I think that's just par for the course. This panel is not really great when it comes to gaming. I just turned off the overhead light, might make it a little easier to see what's going on the camera here. All right, well, I perished. I have a copy of Planet X3 from David Murray on this floppy as well. If I only copied the CGA files, it actually fits on there along with the Arkanoid game. And similarly, the shades of orange look better than the CGA color palette, if you ask me. Let's enter the game here. And because this is an 8 megahertz or 286, performance is actually pretty good as well. Yeah, you can see it's animating quite well, and yeah, it looks pretty good. This is quite playable right here. Now, other observations about this machine, by the way, is the arrow key layout is pretty unintuitive and difficult to use. You have up and down over here and left and right there. So it's very non-standard, and it's tripped me up a whole lot. Using this computer, you'd obviously get used to that. But for me, using this thing right now, it's very frustrating. It would be so much better if it was left, right, up, and down, and they just made the shift key, like took off one key there, and then they could have moved the delete key up to there, for instance, or moved a couple of these keys up to there, and it just would have made the layout so much more intuitive than the way it is right here. So that's going to be it for this video. The computer here is about as good as it's going to get. It's too bad we couldn't even do, well, really anything to it. It's kind of funny in a way, all that work I put into this machine, and the reality is all I actually did was take out a dead hard drive and change the battery to something that can be easily swapped in the future. It's unfortunately kind of par for the course with these old 80s laptops. They are so compromised and so difficult to work with that your expandability options getting them is very limited. With a whole lot of reverse engineering, it might actually be possible to, for instance, put an ISA compact flash adapter in this machine. It would require custom making a PCB and figuring out all the signaling and whatnot that goes into it. So it's quite a lot of effort. And since I think you probably tell watching this and the Samsung S5200 video too, I really don't love this era of machines. I mean, I love desktop computers from this era, but the compromised clunky laptops that we had back then are really just not my favorite. And it's really one of the reasons why I never really focus on laptops on this channel of any era. They are just not my thing. And the only thing about this computer that makes it cooler than other clunky laptops from the 80s is the awesome plasma screen, and it is fully functional, which is awesome as well. If you have personal experience using these types of computers with plasma screens in the past, I would love to hear your feedback on what it was like to use these machines at the time. Was the fact that the screen is not able to display shades of color properly an issue for you? And also, was the plasma screen brighter back in the day than they seem to be now? It's kind of my assumption that just like a CRT, these plasma screens probably get dim over time from use specifically. So this thing maybe is just dimmer than it was when it was new. Although I don't see any kind of burn-in or anything else on here, which I know is totally possible with gas plasma screens. So if you're still watching at this point, I know this video was pretty long. I do appreciate it. I hope you enjoyed me fiddling around and punishing myself working on this computer. Thanks very much, Peter, for shipping this to me from Germany, and Berend for originally supplying it to Peter to actually ship to me. I'd also like to give a huge shout out to my patrons. Their names are on the side of the screen. They make it possible that I do this full time, so I owe them a huge debt of gratitude. So thank you very much to them. You can become a patron. There's a link in the description below. You get behind the scenes access to stuff and early access to videos and whatever stuff like that. And the usual YouTube junk, subscribe, thumbs up, blah, blah, you know, the usual thing. And that's gonna be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye. Boy, this computer is noisy, and under the studio lights, it is almost impossible to see the screen. We'll just turn this off now.